Yesterday we had just begun discussing optimization problems for functions with two or more variables. And let's consider this case right here. Suppose z is a function f of x and y. And let me change the notation a little bit. Let me use a more convenient notation. Notice partial z, partial x could also be denoted by just f sub x. Also, partial z, partial y. Another notation for this is f sub y. Furthermore, the second derivative of z with respect to x, which can be written this way, is just f sub xx. Also, the second derivative of z with respect to y, which can be written this way, could also be just f sub yy. And then finally, this cross partial derivative, partial z, partial x, partial y, this is just f sub xy. Okay. It's actually more convenient, I think, to use this notation. So using that notation, then the first and second order conditions for a maximum and minimum are given in this table. For a maximum, the first order necessary conditions, first order condition. Patrick, you were squinching your face a little bit. Okay, all right. The first order conditions are just f sub x equals f sub y equals 0. And of course, these are the same first order conditions for a minimum. First derivatives be 0. The second order sufficient conditions, SOC, are for a maximum that f sub xx and f sub yy both be negative. Okay? And furthermore, that f sub xx times f sub yy must be greater than f sub xy squared. For a minimum, the second order sufficient conditions are these first two derivatives be positive. And this condition must also hold.